There we are.
Well, hello everyone. I'm Kelly Beatty, and we want to welcome you to this hangout here. I'm on the board of directors of the International Dark Sky Association, which is hosting this. We're doing this in conjunction with the International Year of Light. We'll mention a little bit more about that in just a second. Today, our topic is going to be the influence of light pollution on wildlife and the nocturnal habitat. And we've got two fantastic speakers to make that possible for you. I just want to introduce them now. Well, before I do that, let me just mention that real kudos need to go to Connie Walker, who is working behind the scenes. She's the one who organized this. You'll see her pop in from time to time, but she's basically going to be running the PowerPoint today. Connie's also on the board of the IDA, and she's on the staff as an astronomer at the National Optical Astronomy Observatory in Tucson, Arizona. So we're kind of spanning the gamut here. Let me introduce the two guests today who will be speaking with you. One is Andreas Haenel, who is director of the planetarium at the Museum am Schlurberg in Osnabrück, Germany. And he's been fascinated with the effects of light pollution on wildlife for a great deal of time. He's been very involved in getting two reserves in Germany to become part of the Dark Sky Reserve Program in the IDA's Dark Sky Places program. You can see more about him there. He's received the Galileo Award, which acknowledges his efforts to control light pollution in Europe. And the other guest that we have today is Travis Longcore, who I know has been in this for a very, very long time. He's an assistant professor of architecture and spatial sciences at the University of Southern California. Go Trojans. His particular interest is urban ecology and conservation. And you might know his name because he co-edited with Catherine Rich a decade ago a landmark book called The Ecological Consequences of Artificial Night Lighting. And I know that this book was really the first to bring to widespread attention the connections between light pollution and the nocturnal ecology. So we're in for a great treat. They have a bunch of studies and other important points to make in the hour ahead. But let me just give you a little bit more background about the IDA and the International Year of Light. This International Year of Light is something that we're celebrating this year, and it is in part because of the anniversary of the Einstein's 100th year of general relativity and that effect on light and how we think of space. But part of that is the cosmic light theme and how we perceive light coming to us from the cosmos, not just in our earthly environment. And preserving dark skies is an important part of that cosmic light theme. And so the IDA has been partnering with the IYL to try to bring that message to the widest possible audience. And so to do that, we've sponsored 6 of these Google Plus Hangouts over the course of the year, spread out over 2-month periods of time. Today, as we mentioned, the focus will be light pollution's effect on wildlife and also some of the solutions that are possible, so it's not all bad news. And just a little bit about the IDA before we move on to our guests. The International Dark Sky Association has been around for more than 20 years now, and we are the ones who are leading the charge in the fight against light pollution in all its forms. Those that affect ecology, the impact of light pollution on energy consumption, certainly the impact on our appreciation of the night skies and on the human consequences of too much light at night. And it's a lot of territory to cover, which is why we have these 6 Google Plus Hangouts, because there are important points to be made on each of these topics. So our overall goal is to educate the public, to work with administrators, and it's an ongoing battle, and we appreciate your support in that. So today we're going to be addressing light pollution's effect, as you can see there, on flora, insects, fish, seals, birds, and much more, and of course trying to address some of the solutions that will take place that are possible on all of these. So I think what we'll do is just get started. Andreas has and Travis have put together a terrific set of PowerPoint slides, and we're just going to kind of talk to them and around them. And Andreas, if you want to take it, please do.
Okay, hello. I have here a picture as an example how artificial light influences plants. You see here a tree in winter, and you see some leaves. These leaves are still just around the lamp. So you see, lamp is the artificial light is influencing the growth of the trees and the leaves. And it is interesting just to mention once a student of the university in Osnabrück, he asked me about the times of new moon, because they have observed, if they go to the fields, that even moonlight could stimulate the growth of shoots. And you know, moonlight is a very, very low intensity, 1/3 of a lux perhaps. And so you see that even very faint light, and especially artificial light, could also influence the trees. And we can see this, we use it in the next slide. You can see that we use this, for instance, in greenhouses that we can get in winter, roses and so on. And the country that is affected most, at least here in Europe, is the Netherlands, where we have large areas of greenhouses. You see here the greenhouses are even brighter than the airport, and the airport Amsterdam, one of the largest airports in Europe. And the interesting thing is, if you look there in the next slide, that these greenhouses emit a lot of light. They have large light domes over all the many cities in the Netherlands. And the interesting thing is that you can see this only in the second part of the night, because the greenhouses are mostly switched on only at midnight. So they think that most people sleep in the second half of the night, and then they can be switched off. And the other interesting thing is that they are often shielded around, but not to the up, so that the light can go up, but not in the surrounding. But we know it disturbs still people, and we also know that these greenhouses, the illuminated greenhouses, attract a lot of insects, for instance. And so I think they change the natural environment a lot.
Yeah, so Andreas, this as we talk about agriculture, you know, there are instances also where lights can, here it's used to facilitate growth, but it also can inhibit certain things happening in the course of the season. And I think this is a great time to talk about the how light is a signal for seasonality, right? Because day length, through much of, you know, outside of the tropics, day length is this really great signal that tells plants to do certain things, or tells humans or other organisms to do certain things at certain times of the year. And so there's been research done on soybean production relative to the signal of how long the day is, and that is influenced by the amount of light. And so we've shown, and people have shown in the United States. Actually, the research wasn't in the United States; it was done in Korea, and there was a field of soybeans. There's some great pictures of things like this, where they are able to show that the middle part of the soybean field is all set seed and the soybeans have died, but then around the edges where there's street lights, the soybeans are still alive. And you'd think that's good, but it's actually bad, because it means they're waiting for the day length to get short enough to set their seed. And so this also varies by the type of soybean you're talking about. But this is a way in which light pollution can actually cause decreased yield in a farmer's crop if it's giving a signal of the wrong time of year relative to the growth of the plants.
So go ahead, Andreas.
I think Travis could talk
Oh, okay.
better about the
Yeah.
insects.
So this is kind of like a fireside chat where we've got a bunch of. It's like go into your the slideshow, the old slideshow, and it's like, yeah, who remembers when we went to that farm? Uh, so insect attraction is an issue that I've been working on a little bit. And so this chart that you see right now is showing a wavelength along the bottom. So the short wavelengths on the left side of your screen are the blue, and the long wavelengths are on the right side of the screen. Those are your reds and your yellows. And so it's basically demonstrating a rainbow from the left to the right. And there's three curves on there, and the blue curve and the green curve are the ones showing the insect attraction for moths and actually for honeybees as well. And you can see how they're very much over toward the left side of the chart, and a little bit of a hump there in the middle. And then the yellow curve is the emission spectrum, relative emission spectrum of a 3000 Kelvin color temperature LED bulb. And 3000 is actually on the warmish end of what you get of color temperature, so it looks a little more yellow. On other LEDs, you'd see a much higher spike there down in the blue. But the thing to notice here at the outset is that how much a light source intersects with the attraction spectrum for insects will affect how many insects it attracts. And so there's been a series of studies that show and illustrate that we'll show you some results from of how different lighting types attract insects in a different way. So I think the next slide gets us started on that.
So Travis
So
is
Travis,
explaining.
if I can jump in. So this explains why if you have a yellow bug light or even a red one, it's not going to attract moths strongly because those wavelengths are not in the sensitivity of the moth's eyes. Is that it?
Exactly. Yep. And this is one of these sort of puzzles that people around the world now are working on, which is trying to figure out, are there general rules for this that we can apply across the board, or are there variations by groups of organisms that we need to be able to how many different groups do we need to break it down to? Because of evolution, there's a lot of similarities among groups that are related from an evolutionary perspective, but there are ones that are different. And so this is a real area of trade-off between the specificity of how, so we're trying to look for these general rules that are applicable to the maximum number of species.
So Travis, this graph also shows, I think, that if you had an LED light that was 5,000 K, because the one you have there is 3,000 K. They qualify that as a warm light, but if you had a cooler light, then that peak would shift over toward the blue and intersect more with the vision of different insects. Is that correct?
Right. So the colder looking lights, the ones that are more blue, we describe that as being cold, but because of how we do lighting in common conversation, we refer to that as being a cold light, even though the color temperature is high. It seems a little bit counterintuitive, but a cold light that has a high color temperature has more light in the blue, and that in general is going to intersect more with the vision of insects. Now the thing beyond that is ultraviolet, because, and this is something that comes out as we start looking at some of these results, is lights that have ultraviolet in them, which we as humans cannot see. They are especially attractive to moths, and moths are sort of notoriously attracted to ultraviolet light. And that's why the old mercury vapor lights that have ultraviolet in them, or any light with ultraviolet in them, are really just moth magnets.
Yeah, I think we see this in this slide here. That's an experiment done by Gerhard Eisenbeis, a biologist from Mainz University at Düsseldorf on the Rhine River. On the left side of the slides is the Rhine River. And they have put up here different luminaires and different lamps. On the left side, you see the cold white blue LED with a color temperature of 6,500 degrees. Then you see that's only one LED, warm white LED with about 3,000 Kelvin. Then comes the typical yellow high pressure sodium. I can I think when we put on the description of this slide, Connie, you could please put on the, yeah, and then you have this typical yellow sodium high pressure lamp, then the typical green light of the mercury lamp, but that's the lamp with a lot of UV emission, we can't see it here, and then the metal light emission. And these lamps have been used to study how much and how many insects they do attract, and the result we can see in the next slide. There you see the distribution or the numbers of the relative numbers of the insects. You see that mercury, that's the red bar, attracts most insects, and metallolite a little bit less. And fluorescent, these are the dark blue bar, about half of the insects. Like also the bright blue, the sodium high pressure, the yellow lamps, they attract about less half than insects than the mercury light. And finally the LED, and you see that the LED attract less insects. That's just 20% of the mercury high pressure lamp. Well, this study had some faults, also some drawbacks, because the lamps had different brightness and different brightness distribution, so that could not be very well compared. But they made another test in the following slide at Frankfurt, another large city in Germany. And the interesting thing is there that the results were more or less the same. They didn't use any longer mercury, because that's no longer used now. Instead, we have metallolite as reference. That's the red bar, 100%, and you see sodium high pressure. The yellow attracts less, so it's more or less the same result. And here they have distinguished the color temperature of the LEDs. So the blue, the neutral blue LED with 5000 Kelvin LED shows that they attract more insects than the warm white 3000 Kelvin LED. They attract really the less insects, only a third of the metallolite lamps.
Hey, Andreas, this is Kelly. Do you know whether this particular study made any accommodation for the intensity of the light from these various sources?
Yeah, that was very important. They used the same intensity for the lights, but only the LED had about half the intensity, because at this time they could not use the same brightness. They were not yet available LED that are so bright.
Yeah. So if I could add something about that, and this is really an interesting thing when talking about light in general, is that the intensity is on, the perception of intensity is on a logarithmic scale, and the measurement is on a linear scale. So that means even if you double the intensity as we measure light, it doesn't really, you can notice it, but it doesn't seem like it's doubled, right? And so it turns out, and we did this on a study where we were comparing compact fluorescent bulbs and LED bulbs for attraction of insects, and we've used intensity as sort of a covariate in our analysis, and we found that even for about a doubling of intensity, it was less important than the spectral composition of the lights. And so that is a really important thing. And remember, because we see light, and other species do as well, over, you know, huge orders of magnitude differences from being outside in the middle of the day to you know, a dim starlit night. This is multiple orders of magnitude. So doubling is not that much if you think about it really in the illumination world. If we measured light differently, it would be built in, but it's not, and so that leads to a little bit of confusion there.
Okay. Here another example, because it's always said that LED attracts less insects, especially industry. The firms tell, and that's an argument to sell LED lighting, that they do attract less insects. But that's just another example where you see that even LED lighting, even warm white LED lighting, attracts a lot of insects. You see on the right side, that's a bridge over a small river, and it's illuminated with LED, and the LED is shining directly to the river, and insects going up. And you see on the left side the spiders put up their net because they get a lot of feed by the insects, so they know where the insects are coming from. And you see here really that LED do attract also insects.
Right. So I think, the reason that we're talking a lot here about LEDs is this is the new lighting technology that's coming. There are sort of massive efforts around the world to switch lights from older technologies that have different spectral characteristics, like the orange glow of a high-pressure sodium that you might be familiar with, to a full spectrum, meaning all of the wavelengths of the visible spectrum LED lamp. And so this is an area that is getting a lot of attention and research right now relative to the effects both on wildlife and on human health. And the thing about it, though, that I think is really interesting that we've already seen is that with LEDs, you are not locked into one set of spectral outputs of light. You can configure them and filter them to produce just about any set of wavelengths that you might want. And so it becomes an even more interesting question because there's such options available, and there are some perhaps economic trade-offs depending on what you do, and there's all these potential impacts. And the blue light question, because we're emphasizing that insects are attracted to blue light, shorter wavelengths, ultraviolet light, happens to also be the wavelengths that are most disruptive of circadian rhythms, the daily rhythms that basically every organism that lives outside of a cave on the planet has. And so the intersection of the wildlife impacts and the health impacts in terms of circadian disruption, and then the aesthetic issues of what do people like lights that look white, or would they be comfortable with something that perhaps it looks more yellow, is a really active area of research, and we're trying to come up with in the scientific community. This is why there's such this emphasis on
I think we just lost
spectrum in the past.
Hey, Travis, you want to repeat that last statement because we lost you for just a little blip there. This is why there's so much emphasis on what?
On this in the research community, because now we can play with spectrum in a way that we couldn't in the past, right? And so it's energy efficient. So there's going to be I think a real continued growth and emphasis here, and I hope solutions, because we can tune these things to such a way that we can avoid those areas of the spectrum that have the most impacts.
Okay.
That's just an example from France I found for making citizen science in comparing collecting insects at artificial light and at the same moment to look for the brightness of the sky, so to look for light pollution. They collected insects. That's a book where they can find which insects they observe. They could look for numbers, and at the same time they look which is the faintest star that's visible, so how strong light pollution influences the visibility of stars with the constellation of the Cygnus, the Swan, to look for the faintest stars, and then to correlate the number of insects that can be observed at this place and the brightness of the sky. I unfortunately do not know anything about the results.
Right. Well, there is an interesting observation to be made here, and that is that it turns out in many studies of moths that places where there's a lot of light pollution, it kind of washes out the entire environment, and attraction to a single lamp may be less, which is an interesting sort of result Now, it doesn't mean there's no effects of the light pollution. It just means that there's so much light they don't necessarily know what to be attracted to and where to go. But it brings up a really interesting point that I was discussing with some people in the National Park Service yesterday, which is the decision to add one light to a remote area that has no lighting is a much bigger decision than to add the second light. Because that one light, as any insect collector, moth collector would know, is going to just be that beacon in that habitat and get things. Now that second light's a much smaller decision. And so this decision at the beginning of, do we need light in this potentially natural area that's being managed for natural purposes, is a big question. And the first one's the doozy.
Okay.
Yeah, that's just an example showing how artificial light influences also the water, the fishes. For instance, the top picture is an example of how illuminated fishing boats are used, for instance, in Croatia to get more fishes. And on the other hand, more and more bridges on rivers are illuminated, and it's very well known that such lights are barriers for the fishes that need to go up the rivers, and they have problems to go through these lighting barriers.
Right, and this is sort of another general class of impacts that lights have on wildlife, which is the impact on movement across the landscape and sort of wayfinding and direction finding. And so this is an example from fishes, and the bridge becomes a barrier because it's lit, but we can look across taxonomic groups and see a whole bunch of different examples about wayfinding like this. So for example, there's a study of dispersing juvenile cougars in Orange County, California, showing that they wouldn't go toward the city lights at nighttime. They'd sort of sit and wait and not go there, and consequently would miss some places where they might otherwise have gotten under a freeway into a new habitat. Or the movement of birds as they migrate, meaning, and they're running into communication towers, or we'll get to that in a second, tall buildings. Or another example might be the movement of hatchling sea turtles as they come up out of the nests in the beach, and they need to decide where to go to get to the ocean. And so each of these are examples of the general function of lighting creating a barrier or disrupting wayfinding in an organism.
It's just another example how the orientation can be changed. These are seals. That was an experiment made also by some German biologists. They put up a planetarium over a basin for seals, and then they looked if they orient towards stars. And the interesting thing was that they seemed to use at least the brightest star Sirius for orientation. So if you have light pollution, you can't see the stars, then they perhaps get also difficulties in orienting according to the stars, like we know it from many migrating birds, I think so.
Yep. So birds also, and so I think the next slide has some discussion of birds, but before you speak to this German example, the birds, of course, can use stars to orient. They can also use landmarks on the ground, and they also have a magnetic compass that they're able to actually detect the magnetic field of the Earth. And so this issue of birds running into buildings is just as a little, and obstructions, just as a little background. Turns out that magnetic compass, so the situation in which it happens are ones where the birds are going to get pushed downward as they're migrating, and these are birds that generally are songbirds that are migrating at night, going from some northern locale to some tropical locale for the winter time. So we have these massive migrations both in Eurasia and in North America into Central and South America, and so in order for this to happen, you need to have the weather conditions that push the birds down in their flight pattern so that they start encountering tall objects. You have to have, usually that also means that the stars aren't visible because there's clouds and some sort of a front that's pushing them downward. And then the lights are going to either be so bright or of the wrong spectrum that they either are sort of dazzled by them and don't leave the area of attraction, and that's a phenomenon we don't completely understand perfectly. Or they can also not use their magnetic compass, and it turns out that the spectrum of light matters there as well, that a solid red light, birds are unable to use their magnetic compass under there, and it has to do with the physics of how that compass works in the eye, that the light excites a molecule and how it spins, how it spins is affected by the magnetic field of the Earth. But without the right wavelengths of light, that system can't work at all. So there's a whole series of things that go on, and light plays into them quite significantly with bird attraction.
You know, here on the East Coast, Travis and Andreas and guests listening in, we have a major Atlantic flyway up and down the coast for migrating birds. And we've had some situations where, at least here in Boston, there's been a voluntary effort during the migration season for the building managers of the tallest skyscrapers to voluntarily turn off their lights at night after some period of time, after some particular time, so to disrupt the migration as little as possible. And that's been pretty successful. The only problem is that once the migration is over, they turn the lights back on and leave them on all night.
Yeah, and there's any number of programs like that across. I think the sort of big original program is the Fatal Light Awareness Project in Toronto, Canada.
That's flap.org.
Yeah, flap.org, and they have a lot of resources about this. Also, Chicago, New York has a bird-friendly building program that's oriented toward having some lighting controls, and people who do this because, and it's interesting to also distinguish between the birds that are going to be killed at tall towers versus the ones that might hit a low-rise building during migration. And I think this is something that I think will emerge as time goes on even more. But the tall buildings, really, it's about the light and the nocturnal migrants being attracted by the light at night, and they're killing sort of a different set of species than the ones that are at a residential building, which may be more localized, or maybe some migratory birds stopping through. But you get those attractions going on because of lighting at communication towers and at tall buildings.
That's just an example for this. That's remarkable because there were long time study, and it showed when they switch this sign, 50 meters high sign, switch it off during migrating time of the birds, they had much less collisions of the birds with this illuminated sign than before. So that's just one example. And the next slide shows another one that's also switched off. That's the Post Tower. That's one of the rare skyscrapers in Germany. The Post Tower that's illuminated in different colors, and they try to find out if the colors have influence. But in this case, they found it doesn't matter which color is used. All colors attract birds in the same way. And even this building in the next slide shows that these are the birds that are attracted: common firecress and European robins. These are the main birds here, and you see that these are very nice birds also. And on the next slide you see that even from far distance, from 1 kilometer away, the birds are attracted by this skyscraper, and that's just one example. And here the skyscraper is also switched off during the migrating time of the birds.
Right. And so the other place where this happens is at tall communication towers for radio and television. People sometimes describe that as cell towers, but cell towers are actually very short. We're talking about things that are 1,500 up to 2,000 feet tall. And we did a study a few years ago that brought together a database of all of the towers in Canada and the United States. And so we had this map, and we had them all mapped out by height. And then we looked at a bunch of longish terms, some longer than others, some up to 27 years long, some maybe a couple of years long, about the number of birds killed by tower. And it turns out that height is a really important thing. And then also, and all of these towers at that time were really illuminated basically in the same manner, which is with a solid red light and then flashing red light and then a solid red light and a flashing red light. And so we calculated that the number of birds migratory, and this was 95% songbirds that are migrating, at night, was 6.8 million birds per year, a million with an M, just at tall communication towers in the United States and Canada. And that number could be cut probably by 70 or 80% by one simple lighting change. And that is, instead of having the solid red light and the red flashing light, you just turn off the solid red light. And so when the flash happens, then the birds the spell is gone and they can move on. It's that solid light that's the kicker. And that's research that was done out of Michigan by Joel Gehring. So that's a really interesting instance where there's a solution. The solution saves money. And this has now been taken through the FAA, the Federal Aviation Administration, to show that turning off the solid red light is just as safe for pilots. They can see the obstruction, because that's the only purpose for the lights, is for the pilots to see the obstruction. And now the FCC, the Federal Communications Commission, is allowing and actually encouraging tower operators to switch off that solid red light and eliminate that risk. It's not eliminated entirely, but when you take 6.8 million, and it's really the tallest towers that are doing the most damage, by a very small number of retrofits, you could reduce that number in half or a third and save the tower operators money.
Yeah, that's just a funny, just a funny example. Birds resting, nestling in a lamp, but it just shall demonstrate the birds in cities with artificial light are influenced a lot. They change the time of breeding, and they also start earlier singing in artificial light, and in the evening they sing longer. There have been done a lot of studies showing this. So this just shows how the artificial light in the cities changes the life habits of the birds.
Yeah, and this is a great example here. And of course, the bird in the light post, the nest in the light post, isn't what the studies are of necessarily. They're actually measuring lighting levels at nests. This is a bit of an anomaly to have the bird in the light itself, the nest in the light itself. And there was a paper that just came out today from the group in the Netherlands that's researching this, looking at different colors of light and the stress hormones that are in birds. And what they found is that birds that were nesting in areas that were lit by I think they had red and green and no light and yellow, I want to say, or no, white. They all had increased levels of the hormone cortisol, the stress hormone, but there was a little bit of a distance decay effect for red lights, and this is consistent with some other things. These long wavelengths, the warmer colors, tend to have sort of less effect on these sort of circadian rhythm issues, and so this is a great example of where physiology is being affected. Talking about, as Andreas was saying, the timing of egg laying, whether or not egg laying is going to happen, and then also we now have this evidence that it's actually affecting stress levels in the organisms, as we can measure those as well.
Yeah, that's an example we have now in Germany and Europe, because the change to ecological light, ecological electricity So more and more windmills, offshore windmills, power windmills are built on the sea. So all the places on the sea that were dark before are getting now bright. And also we have the problem that the migrating birds over the North Sea or the Baltic Sea are disturbed in their normal routes, and they try there with different, just as Trevor told, with different colors and also different frequencies of flashing red lights. They mainly use blinking red lights or yellow lights, but nevertheless, all these lights disturb a lot.
Yeah, and I know maybe Kelly would do this as well, but I encourage people who are listening to go ahead and put questions up. If you have, I think there should be a opportunity. We've had some questions regarding the slide views and whatnot, but if you have substantive questions, otherwise, Andreas and I think are capable of talking for several hours uninterrupted. So get your questions out there.
I was just waiting for a moment's pause to cut in and make that.
I was giving you that.
But on this issue of the windmills here in the U.S., as you mentioned, Travis, these red lights are primarily for air safety. Mm-hmm. They're certainly not for the birds' benefit. And there's a movement to develop kind of a motion sensor, if you will, based red light, where it will pick up the frequency of a transponder from an airplane and only then turn on.
Yeah.
Have you seen much widespread adoption of that? I think Nancy Clanton, who's a former director of the IDA, has been involved in that research.
Yeah, I have heard about these and poked around a little bit on it. The thing about these massive wind arrays is that so far in the United States they've only been lit by flashing lights, and as long as those lights are synchronized, those lights themselves aren't going to be a big attractant to migratory birds. However, the problem happens when you have facilities on the ground, because these are often remote areas, and those ground facilities are lit, and then during adverse weather conditions, birds actually get attracted to the ground facility that is associated with it. And so that's one of the really practical recommendations that come out. Of course, none of these mitigations deal with the number of bats that are being killed by these towers, unfortunately. They get hit pretty hard with them.
There have been done some research, and there are also some solutions in Germany, and they are now also allowed, as far as I know, to use these transponders to put them on the windmills. But these on the sea, they must be illuminated for security reasons, also for the ships. That's the problem.
Yeah.
That's just the study that has already been done 100 years ago. That's how lighthouses at the island of Helgoland attract birds or disturb birds migrating. They found there are hundreds of birds near this lighthouse. And the question is now if lighthouses are still necessary, because the boats are using GPS and they have digital maps. So that's really a question if lighthouses are still necessary, but there's also, I think, a certain tradition that they are still used, and like the one here, they use very, very narrow beams, and perhaps that's not so problematic when they use such narrow beams. Okay.
Okay, it looks like we have some questions we might want to address while we're talking about.
Right. Thank you very much. And these come from Audrey Fisher. I've got 4 questions queued up. I'm not going to necessarily explain them all, but one of them is whether there's a color conflict with the needs of birds versus light scatter. That is, for example, we typically recommend red or yellow lights and not blue, but I've heard that birds are attracted to red and yellow. Is that the case?
Okay, so this goes back to this sort of physiological mechanism of why the red lights on the towers, why we think it's an issue. This has not been actually proven. This is just putting together the sort of sets of understanding about how these things work. The reason the red, it's not, They are attracted to red light on tall towers. No question, we've seen that. We think the reason that happens is that they're attracted to the light, and then they can't use their magnetic compass because red light doesn't allow them to do that. The solution for tall towers, and we're talking about things that are 1,500, 2,000 feet in the air, is to simply go with flashing lights instead of solid red lights, and that's then it's not really a spectrum issue; it's a duration issue. And this does, though, get to the challenge of there not being a silver bullet solution to all situations. So I'll give you another example that's sort of similar to this. The turtle lights, which are lights that have basically no blue in them. They're used along turtle nesting beaches because the turtles can see them, but they react less to them. Turns out that the endangered beach mice in Florida that are on the same beaches as some of the turtles, they're also affected by the yellow light. So, and it's probably because there are different, processes going on in terms of what the light is being used for. Light can, in the one instance for the turtles, is being used for wayfinding, and in the instance of the beach mice, it's being used for object identification. And so sometimes light's just light, and if there's light out, it's going to affect some species. But in other instances, you can minimize the effects by using specific spectra of light.
Sure.
And so so the answer to that is I would not avoid using warmer wavelengths because of worrying about birds.
Right.
There's other solutions to deal with birds.
We've got a great question here from Tony Brissati. Thank you, Tony. Which is basically, can a lot of these issues involving the distraction of migratory birds be eliminated if the lights were simply downward pointing and illuminating the ground? Is it that the birds are seeing the actual sources of the light, or does the light have to be at their altitude where they're flying?
It's a great question. I think that downward-facing lights in general are going to minimize these effects, reduce the effects, but depending on your surrounding environment, and if we're talking here specifically about night migrating songbirds, there are instances where you have a pool of light on the ground that ends up being the attractant in an open habitat. And other examples we have of a parking lot that's illuminated downward by lights, but the parking lot is wet, and migrating waterfowl perceive that as a place where they can land at night, and then are killed as they collide with the pavement that is not water as they expected it to be.
Right.
So and so to generalize back to that, to sort of all of sort of ecological impacts is, in general, doing things that are good for reducing sky glow, light up into the sky, are good, but they may not always be enough in certain instances. It's not going to hurt, but if it's shining down into a wetland, or it's shining onto something that then becomes an attractant, and this goes to another question that's up there, the sort of the wet parking lot issue, is going to have a lot of polarized light in it, and I'll let the physicists here explain the difference between polarization of light, since I am not one, but that is going to affect and attract insects that are looking for water. So when you have mayflies that come out, and there are examples around the world of mayfly hatches out of streams, and they all, instead of laying their eggs in the water, thousands of them at a time end up on bridges or parking lots that are illuminated and maybe a little moist, and that gives them this this signal that it's water through the polarization.
Interesting. And so we've got a couple more questions, and we'll get to those, but we have just a few more slides queued up here, and I just want to make sure that we get through those. So Andreas and Travis, if you want to continue, we'll kind of carry on here.
Next slide, perhaps. Connie?
You want?
I just want to say something. You see here how light pollution has increased during the last years in Central Europe. And I think the main or the important information here is that you see that dark areas that you had before, for instance in France or in northeast of Germany, the dark areas, that these are bright, becoming brighter and brighter, that there are coming lights in. So these are really disruption of the dark areas that still have existed. What's happening in the cities is not so important, because there the changes are not so much, but that lights grow out into the nature, and that's, I think, one of the important things that more, especially in the densely populated Central Europe, that if you have such dark areas, it's also important to protect these dark areas, and that's what I'm interested in, that you have these dark areas even in densely populated countryside, and should protect them to even to have, not only to have a good look at the stars, but also to protect nocturnal species.
It's striking how the most, to my eye, the most dramatic increase has come from Benelux, Belgium, the Netherlands, and Luxembourg.
These are the most densely populated areas.
Yeah, incredible.
I'm amazed at how much growth there's been in 10 years, from 2000 to 2010.
Yeah.
Yeah, but that's also a problem.
Because lights are growing faster than population.
Yeah. Yeah.
That's also a little bit the problem of the sensitivity of the detectors of the DMSP satellites.
Oh, and the DMSP, for the public to know, that's a satellite that's been orbiting the Earth and taking photographs at night and I guess during the day too, but nighttime pictures mostly.
Yeah.
Yeah.
Defense Meteorological Satellite Program. Yeah.
But this will that will change with the new satellites, because, or the new satellite, because there we have calibrated pictures, and this will give us a much more accurate information now.
That's a Suomi satellite with the VERSE detector.
Yeah, yeah. Well, that's one example of a national park in Germany. Near to the national park, you have such a sky beam from a discotheque, and you see how far it can be seen. So this should not happen.
Wow.
Yeah, we have a situation like that. The National Park Service's night sky team did some all-sky photography from Death Valley, and there's a huge light dome from Las Vegas, which is about 50 kilometers away, 50 miles away, I'm not sure which. And in the images, there's what looks like an artifact, just a straight line up and down, and it's not an artifact at all. It's the spotlight from the top of the Luxor Hotel in downtown Las Vegas, visible from those tens of miles away. It's really kind of tragic.
And if you look closely, you can see all the birds and maybe bats, I'm not sure, maybe Travis can tell us, circling the light, being in the light beam.
Yep.
And that's just what we are doing here in Germany, because we have 3 different large-scale areas, nature-protected areas. These are nature parks, biosphere reserves, and national parks. And the interesting thing is that nature parks are about 1/4 of whole Germany, and we are now working there on to get something with them to protect or to put the theme of light pollution, or to putting up better lighting in these nature parks. Then we get already a regulation. We would get already a regulation for 1/4 of the surface of Germany. So we want to show that in these different categories, 3 different categories of large protected areas, it's possible to put up star parks, and that's what we have managed now in Germany.
Is this the same one, or?
Yeah,
it's on the right side. You see these nature protected areas. The black hashed are these nature parks brown is the biosphere reserves, and green, these are the national parks. You see, these are the smallest areas, and it's here compared with the Cinzano light pollution map that the Italian astronomer Pier Antonio Cinzano has done. And you see where you have the dark areas. These are the blue and black ones. The black we have none in Germany. We have just in Poland, and you see only the sea, the North Sea and the Baltic Sea are black, but that's changing now, and the red circles are some of the areas where we are now working on putting up or protecting these protected areas also at night.
Mm.
So you see, one can do something to protect, help to protect the night. What's this? The question, even planetariums are considering light projections.
Yeah,
This is the question.
It's to you know, to attract visitors to the planetarium. But since we're stopping for the questions, Audrey, who made that point, also has an interesting one. Getting back to the bugs for a little bit, is there any kind of work that's been done on the effect of light pollution on honeybees?
To my knowledge, no. I think that you know, this would go into the class of impacts of diurnal species that are affected by night lighting, and consequently, and we have a whole set of examples from around different parts of the animal kingdom of how activity gets extended into nighttime hours under lights.
So you mean by diurnal species, you mean an insect that's normally active during the day, as we think of bees, and maybe by light pollution they're coaxed into being out late at night when they shouldn't be.
Right, or some sort of synchronized activity gets desynchronized around dawn. There are some examples of that go on as well. And so now, and the question that someone would say is this is it necessarily bad? You know, it's kind of, maybe it's good that they can forage more or whatnot. I tend to warn people against the sort of American view that more is always better. You know, these daily cycles are there for a reason. And there may be adverse consequences in terms of stress that we may not know about. There are now some tools that are coming onto the market to monitor honeybee colonies in sort of an automated way, to be able to figure out how much activity is going on an ongoing basis. And of course, it's Internet of Things that's then going to be tied into cell phones and monitoring and whatnot. But this would be a really great thing to monitor honeybee activity at a light polluted or a lighted site versus a naturally dark one, and investigate that question. I'm going to sneeze, so excuse me.
You're forgiven. All right, so maybe then we only have a couple of slides left. So Andreas, you want to press on here?
Yeah.
Okay. Sorry.
No, I think it's finished.
Oh, that's it. Okay.
That's it.
No, but I wanted to just add to that last slide, if I may be so bold. Two things. One is that the national parks in the United States are doing a fantastic job at monitoring at least 90 of their parks across the United States, and perhaps Travis could speak more to that. And secondly, I just wanted to mention that the International Dark Sky Association has an incredible International Dark Sky Places program that people can follow up and look on their newly revised, gorgeous website at www.darksky.org. So please do that. It's called the International Dark Sky Places. And Travis, if you want to, since you're working now more and more with the National Park Service, if you want to say anything about what they're doing there.
Right. So they have a natural sounds and night skies division, and they provide expertise in monitoring for all of the 400 plus national parks in the United States. And you know, we've done a little work. There will be a report coming out relatively soon on sort of the best practices for wildlife-friendly lighting, and that goes over many of the issues that we talked about today. And you know, I think that they're in the process now of figuring out what the next steps are and whether there's policy action that maybe needs to take place to further encourage sensible, effective, and outdoor lighting that really upholds the mission of the organic act of the national parks, which is to, it's to preserve these landscapes for future generations. But at the same time, they have the duty to serve the visitor, to respect cultural resources, to protect the environment of other species. So all these sort of things work together, and as you've maybe deduced from our discussion here today, that there are different ways, there are many different solutions, there are many different problems. The solutions are not always the same, and so one needs to optimize them by making decisions in various areas of and this goes, I think, for any land manager, of what needs to be lit, where does it need to be lit, why does it need to be lit, who is the audience for that, and then balancing all of the other things that go on there to be able to create and maintain a welcoming national park environment and protect the resources at the same time.
Yeah, I want to mention, just kind of jump in here, we have a couple of questions, and I apologize, we're not going to get to them, but they address the general area of, is somebody researching this or researching that? And I think it's fair to say that the interest in the connections between light pollution and circadian rhythms and diurnal activity has really kind of blossomed, and there's now a pretty good cadre of researchers involved in this. Wouldn't you say, gents? Yes? Are there?
I was waiting for Andreas, but I'll jump in.
Yeah, circadian rhythms, there's a lot of work now, but these are especially or mainly on human beings. So I think it's the theme for another hangout where it is discussed. I think we just discussed here the wildlife, not human beings.
Yeah, no, and so the thing is, in the research scene, the physiological, impacts, the circadian impacts, I think are slowly starting to converge, because there's always been sort of chronobiologists who've been looking at human health. There's the Light and Cancer Association, the Light and Diabetes, there's a whole suite of these that have been researched for quite a long time, and they've kind of been different communities in a sense. And we now see with people like Davide Dominioni in University of Glasgow right now, the postdoc there, who's really getting stuff that's about animals and is really looking at circadian rhythms and whatnot. The Dutch group that just had that paper come out today, where we're going from the lab into the field with the physiological impacts. And I think that's a really great emerging area, the convergence that's really only happened, notwithstanding that they've kind of been going on parallel for a long time. These are starting to converge. The person who's really been the leader for a long time, I think, in that field is Abraham Haim at the University of Haifa in Israel. But then there's physiologists like Randy Nelson at Ohio State. And then the medical folks at Harvard, David Blask down in Louisiana. There's a lot of really active research going on, and I'm seeing it in some ways converge. Some ways it doesn't, because the concerns are different enough. But they all kind of come together under this umbrella of the nocturnal environment and the health effects, the wildlife effects, the cultural impacts, and the scientific impacts of changing that environment.
Hey, and I know that you and others, Travis, are working for solutions on this, and the progress is incremental. We're seeing some things that are showing signs of improving, but boy, I'm a little worried about those. The situation in the Netherlands and Belgium. It looks like they're really lighting up the night there. I'm afraid we're going to have to kind of draw this to a close. So Travis, I want to thank you very much for joining us, and also Andreas Haenel from joining us from Germany. This has been a truly international event. For those of you watching live, you can always go to YouTube and catch this in replay. If you want to take a little more time with the slides and digest them a little bit more. And also you can always go to the IDA's homepage to get a link back to the YouTube. That's darksky.org. I just want to mention, you were, Andreas, you were alluding to the human element. This is the fourth in this series of Google Hangouts that we've had. The first three dealt with human health. with astronomy, with safety, and now this one on wildlife, and those are all archived and available to you. We've got 2 more coming up. We're kind of building to a crescendo here. The next one, which will be sometime either in September or October, a date TBD, is going to deal with the light pollution and energy conservation and energy waste. That should be very, very powerful. And then finally, we're going to end this with the role of light pollution and our culture, our heritage of night skies, and what we've lost over these decades due to this growing concern. So I want to thank you, gentlemen, both for joining us. Thank you, Connie Walker, for spearheading this effort and making these available to us. And thank you to our guests for joining us today. It's really great to be able to have this word get out, and we look forward to seeing you at our next Google Hangout in the coming weeks. So for the rest of us here at the International Dark Sky Association, we wish you a pleasant day, a dark, clear night, and we'll see you soon.